In this video, we're going to finish up talking about structs. So there's not a lot of code in this one. There's just some charts and things like that from the book. So I figured I would just pop up the book. Okay. So the first one, it seems, I think it seems more than it really is, that structs seem like arrays. Okay. And they are a way to collect data, but an array is used to collect one bit of data, a whole bunch of copies of it, the same thing over and over. Has to be the same type. Okay. Where a struct allows you to gather information of multiple types about one item. Okay. So structs are almost singular in some ways. They're a compound data structure. They hold everything you want to know about a student or about an employee or about a car or whatever we're doing. Okay. So we're able to make these custom holders for multiple parts of data that we can then give a name. Okay. So as far as looking at the differences when how um, they can be used here. Okay, so you can't add an array to an array. You can't add a struct to a struct. Okay, you can't assign one array to another. You can't make a copy that way, but you can with a struct. Okay, and you typically the input output. Um, you can't do that directly. Okay, we can do strings on an array, but we typically don't. Okay, we can't compare the two except by going through item by item. Now, some of the big differences here, and it has to do with an array is potentially a very large chunk of memory. We don't know how large. So we don't want to make copies unnecessarily. Okay. Whereas a struct is typically smaller. It's a collection of information about one thing. Okay. So it's going to be small. So we tend to we can do that's why we can do the assignment to make a copy of it. We can also pass it by value to a function because it's not going to be so big. We can pass it by reference if we want, okay, but we don't have to do that. And that's the same reason why we can't return an array as a function, and we don't have to. We're passing it in by reference anyway, okay? But on a struct, we can return that as the type for a function if you want, okay? And then, as we did in the homework example, it makes a lot of sense to create an array of structs. Okay, so that's what we did in the example there, where you create student data or whatever we created, and then you have a bunch of different instances of those that you put into an array. Okay, well, we can also use arrays in our structs. Okay, so in this case, we're having this list type that we're creating here. And the list type has two things. Okay. It has an integer that's an array called list elements. Okay. That's up to this array size that we've set as a constant. Okay. And it has a length. Okay. So this is a different way to manage the array. We're putting the array inside of a struct along with the length of the array. Okay. So that could be something that could be useful. Okay. And that's giving you an example of what some of the code could look like there. Okay. So on the list element, since it's an array, you have to put in so it's part of the list, and the list element, that's the item that it is. Okay. So that's certainly something that you can do, which could be interesting. Okay. So here's an example of using the sequential search to see if something's on that list. Okay. So again, we're going to go through, we're going to send along this list type, which is we're going to call list, and then we're going to have the search term. Okay. The same kind of thing. We're going to go through the list. The list has the list element. We're going to use the location, just like we did before on the sequential search. So this can be kind of a handy way to do things. Okay. Here's another example here. We've got a company that's 50 full-time employees. We want to print their monthly paychecks, okay, and figure out how much money has been paid to each employee in the year to date. So we're going to define this record here. Okay, so this is the record for each employee type. It has the first name, last name, their ID. It has their department ID, their yearly salary, monthly salary, year-to-date paid, and monthly income, all of those things. Okay. So this is what we did in the homework example. We're making an array of these. So This is all the information we have about one employee. Okay. So we're going to have 50 of those in an array. So that's what we're doing here. This employee type, 50 employees. Okay. And then it kind of shows how each item in this array is a full struct here. Okay. So that's kind of the idea behind that. So that becomes an efficient way to do that for sure. Okay. And then it's going to go through, and if you're not looking at the code toward the end of the chapters, you should. It gives really good examples. I tend not to assign those because it's a lot of just typing what's in the book. But that's not a bad way sometimes to understand what's going on. Okay. It's also possible that you can have a struct within a struct. Okay. So here's an example of this. We've got this employee type with all kinds of information here. Okay. But we can break this out. Instead of having all of this, we could, for example, have a struct for the name, call it name type as the first, middle, and last, and then a struct for the address type, and so forth. Okay. Then when you do your employee type, it's a lot cleaner. Okay. Um, it does get a little more confusing, I think. So you have to say things like this, like new employee dot name dot first. Okay. Which can be a little extra step. But if the struct gets complicated enough, then I think that makes some sense to do it that way. Okay. And then again, they've got an example here at the end that's a good example to go through. Okay. And I'm just going to hit the very basics of it. But these are bigger programs. Okay. And again, we've got coming up a longer term project we're going to be working on. And these are at the end of every chapter, give you an idea of what I'm looking for on these more fully worked out problems. Okay, so this one, it's going to be a sales data analysis. Okay, so every month these six salespeople go on a road trip, sell the product. We're going to total things up. Okay, so we have the ID numbers, we have each of the quarter numbers, and then the total. Okay. We want to be able to print all this out, do all these totals. Okay. Then we want to figure out who the max sales by person is, their ID and the amount, and the max sales by quarter. Okay. So which quarter had the most? How much was that? Okay. So you can go through and it's going to tell us here, we're going to write a program that's going to produce this output in the specified format. Okay. So if we assume that there's a file that has each salesperson's ID and a second file containing the sales data, okay, the output is going to be a file containing the sales report in that format. Okay. So it's then going to go through, and this is again something that is worth, and I don't cover this enough, and I probably should. This idea of analyzing the problem and figuring out what we're going to do. Okay. So it goes through those steps of how you would figure that out. Okay. So we figure out that the main component for each salesperson are the ID, the quarterly sales amount, and the total annual sales. Okay. So these are different types. So we're going to group them together with a struct. So we have a salesperson record that is a string for their ID, double for their sales by quarter. Okay. So that's an array because there are four there, and then another double for the total sales for the year. Okay. And then we can use that as part of the process here. And then it just goes through and gives us some more data, some more ways to put things together in order to print out this report. Okay. So here's our algorithm here. We're going to initialize the array salesperson list. We're going to process the sales data. We're going to calculate the total sales by quarter, calculate total sales by salesperson, print the report, calculate and print the maximum sales by salesperson, and calculate and print the maximum sale by quarter. Okay. It's then going to go through and tell us which functions we need, spec out those functions as we go along. Okay. So again, this is a good, well thought out example of the entire process to get us to a function that is something we could do on the job, okay, in a job situation. Okay. And finally, there's a whole program listing for that. So these are definitely worth going through. Okay. And then there's the review at the end of each chapter, and we get into the homework problems from there. Okay. So this is a fairly quick video because there's not much new in this part of the chapter. So this is a fairly short chapter compared to what we've done and what we're going to be doing. Okay. So again, the structs are useful when you want to put together uh, a record of some sort, a student record, an employee record, sales record, whatever it is. Okay. So in class, we're going to go through some more examples tomorrow to help us get more skills on this process.